Several people, including firefighters, were injured.
7 people have died in this fire, 28 people have been injured.
Died overnight with burns to 80% of his body.
Is dead.
5 dead.
Seriously injured in this fire.
We keep seeing news about small fires causing a lot of damages.
Especially in developing countries like Nepal, where there's no widespread use of fire detection systems, we are going to demonstrate how easy it is to build one at your home in less than $10.
To create the system, you need a few components.
Arduino Nano, LED bulbs, jumper wires, buzzer, IR sensors, and also water pump. Let's see it in action.
So if you look into our code, we can see many pins connected to different sensor. There is a buzzer pin at 10, which connect to a buzzer for sounding alarm, and there is a flame pin at 12, which connect to the flame sensor to detect the presence of fire. And there are two LED, red LED and green LED at 6 and 5 respectively, which show the status of our system. And there is a motor pin at 8, which connect to a pin controlling a water sprinkle. And if we look more into our code, we can see two functions: pin mode and serial begin. So the pin mode configures pin modes. It sets buzzer, LEDs, flame sensor, and motor pin as output or input. And then the function the serial begin does initialize serial communication for debugging with a baud rate of 9600. And we can see two loop function. If flame is equal to low and else function, the first loop function describe fire detected, and the another else function describe fire not detected. So when the fire is detected or when the flame is low, it turns on the buzzer and red LED, and it turns off the green LED, and it also print a message to the serial monitor named fire detected, water sprinkler activated. And when this condition not satisfied, or when the flame is not low, it turns off the buzzer and red LED, and it turns on the green LED. It also turns off the water sprinkler, and it print a different message which says fire not detected. So this is the code.
Hello everyone, I am Dipin Khatri, and I'll be walking you through the practical demonstration and reflection part of our flame detection and fire suppression system using Arduino Nano. Let's start with the hardware setup. Right here you can see the physical component we have used in our project, the Arduino Nano. This microcontroller, as my friend said earlier, functions as core of our system. It uploads our code, manages the system's operation, and facilitates the communication by transmitting the signal through its port. The IR flame sensor. The working of flame sensor module is very simple. The theory behind it is that a hot body will always emit infrared radiation. And for a flame or a fire, this radiation will be high. We will detect this radiation using infrared photodiode. The conductivity of the photodiode will vary depending upon the IR radiation it detects. We have used LM393 to compare this radiation, and when the threshold value is reached, the digital output is changed. The buzzer, LEDs, and the water pump. These components collectively create a vivid response when a flame is detected. The buzzer emits an audible warning, the red LED illuminates to visually indicate the threat, and the water pump initiates to simulate the fire suppression. Each element in this setup plays a pivotal role in ensuring the robust functionality of our fire safety system. During the development process, we encountered some challenges. One of the significant hurdles involved the fine-tuning of IR sensor sensitivity. Overcoming this obstacle demanded the meticulous adjustment and calibration to ensure precise and reliable flame detection. Looking ahead for the future enhancement of our project, our idea is to add more sensors which would improve how we detect the fire. This would make our system more effective and accurate in responding to different types of fire situations. In conclusion, our flame detection and fire suppression system is not just a theoretical concept, but a practical solution to design for the fire safety. I hope this demonstration provides a clear picture of how simple it is to design a system that responds to potential fire safety and hazards.